So here we need to create these 3-digit integers where none of them are 0. So this example is out, but 2 of the digits are equal. So for example, 252 is acceptable. And I write some examples so that I can also understand what the question is asking. And I need to figure out how many of these are where that remaining digit, so 2 are identical, has to be also different, which means 333 is also out. So one way to do this question is to kind of list out and see if there is a pattern. And sometimes if you're not able to digest a question, that's of course always the best way to start. So it could be starting with the least would be 112, and then 113, 114. So we kind of have something. But then we also recognize that these digits can also be arranged. And this could be 121 or 211. So with 2 identical ones, there are 3 ways I can do that. And you'll recognize that this comes from 3 factorial over 2 factorial, meaning how many ways can I arrange 3 objects where 2 are identical? And that is indeed 3, as we see here. So we have a total of 8 of these, if you're going from 112 to 119, and each one I get 3 different 3-digit numbers. So we have a total of 8 times 3, or 24. And then if we go to 221, 223, because note we'll skip the 222, and then 224, 229, and then we'll get 8 because we're pairing it with the other 8 integers. We're excluding this case where all 3 are identical. And then again, we'll get 3 variants here, so we'll get 24 more. So if we then extend this to 33133, and then finally to 991, so on and so forth, we'll have 1, 2, let me just make sure, 1, 2, 3, 991. We will have 9 of these, and each one gives me 24. So the total number would be 9 times 24, 216. So this is one way you can do this question. The answer is E. The other way would be to do accounting using the counting principle. So if we're just using digits 1 through 9, then we know that the possible number of all 3-digit integers will be 9 times 9 times 9, because we can repeat. So this will be all possible 3 digits, which would be 729. And what I can do is to subtract the ones that are all identical, and that's going to be 111, 222, all the way to 999. So I'll have 9 more that I would subtract. So that would be 720. And then what I'm going to do is to subtract 3-digit numbers where all 3 are distinct. So for example, 521, 783, because these don't satisfy this condition. So I'm coming from the opposite direction, meaning I am subtracting first the number of 3-digit integers where all 3 are identical, and then I'm going to also subtract all 3 are distinct. And this was the all possible, so the result will be the ones where 2 are identical. And to count how many there are 3-digit integers where all 3 are distinct, well, on the first digit I have 9 choices, could be any of 1 through 9. Because I can't repeat it, I'll have 1 fewer, 8, and then 7. So this product is the number of 3-digit integers that I'll have, which all 3 are distinct. So now, if I subtract 720 minus 504, you'll see we get 216, like this. So in the exam, I did it both ways. I had the luxury of time. But sometimes actually going about it this way, under time and pressure, can be harder. So, I mean, of course, you want to go about it this way, but for at least me, sometimes this can be harder, but of course this is the most efficient way. Whereas this kind of at least, gives you an ability to see what's happening, and that can kind of trigger sort of how best to go about it. So I think a lot of these questions, just make sure you can go about them both ways, because I'll just kind of strengthen your ability to take on these questions. Even though this approach takes longer, but I think it gives you more clarity about, why this approach makes sense and why this also works. So to summarize, the answer is E.